So exponent rules. The thing you need to remember about exponent rules is this deals with variables and numbers and their exponents when you're multiplying and dividing. So this deals with variables and numbers that have exponents with them. That's why it's called exponent rules. And their exponents when multiplying and dividing them. So if you're adding or subtracting numbers or variables with exponents, you actually will be combining like terms. So make sure you know the difference. So this will only work when you're multiplying and dividing. All right. So just a reminder, you have two parts to a problem whenever you're working on these types of problems. So you have the number that's kind of to the bottom left, which is a little bit bigger, and then you have the number that's in the top right corner of it, okay? This number right here is called your base, and then this number that's in the kind of the upper right corner is your exponent. And so make sure that when you're writing your numbers and answers to problems that you keep them separate. So remember, the exponent should be smaller overall compared to the base. All right. So if you are drawing your own notes, you'll need to, at this point, make your own little column down the middle of your paper. And then on the left-hand side, we're going to put the algebra and a description of the rule. And then on the right-hand side of your paper, we will be putting examples that go with each of the rules, okay? Now, this is something that you would have done in Math 1. So this is something that might be familiar to you as we start going through it, but if not, then you will have notes that deal with it, okay? So the first exponent rule that you need to know, and you always know that my lead breaks, so here we go. The first exponent rule you need to know is what's called anything that has a zero power with it. So if you have a number or a variable, so I'm just going to use the letter A, and it has an exponent with a zero in it. This rule is super simple. Anything that has an exponent of a zero will actually always equal 1. Doesn't matter how messy it is, it will always equal the number 1. Okay, so just a little description. You could put anything to the zero power equals 1. All right, so let's do a couple examples with that. So what if we had something like this? Okay, well, notice that will equal 1 because you've got x squared times y. Notice you're multiplying them. And all of that is in parentheses, and it's to the zero power. Well, anything to the zero power, and since all of that is technically to the zero power, power is another name for exponent, it will equal 1. So, what if you had something like this? And we have to figure out what that is equal to. If you look, the 2, even though you can't really see the exponent with it, it technically does have an exponent. Anything that you don't have an exponent with is actually to the power of 1. So that 2 has a power of 1. The x, it doesn't have an exponent with it, so it's technically to the power of 1. And then the y has a power of 0. So that's the exponent. Anything that's to the first power is just whatever that number is. So 2 to the first would be 2. X to the first would be x. So they all just kind of come over. But y to the 0, remember, anything to the 0 power is 1. So y to the 0 would actually end up being just the number 1. So then you have 2x times 1. Well, anything times 1 would just be whatever it is. So you end up with 2x as your answer. Okay, so that's the first exponent rule. The next exponent rule that you've got to learn is what to do when you're multiplying like bases. Okay, so I'll use the same letter as I did before. Let's say that you have the base that's an a, and then it has the exponent or power of m. And you're multiplying that times base a with an exponent or a power of n. So notice what I mean by this is you're multiplying. So notice you're multiplying like bases. So remember what we talked about earlier. The base is the number that has the exponent with it. So like in this little part right here, a would be your base and m would be your exponent, or like I've been saying, power. Here, a would be your base and n would be your exponent. And so notice the bases are the same. So that's what I mean by like bases, and you're multiplying them. So the rule there would be when you're multiplying like bases, you actually add the exponents. So multiplying like bases, then you add the exponents. So make sure you remember it's the exponents that you have to add. Okay, so when we do that, the base stays exactly the way it is. So notice I just bring my a over, and then whatever these numbers are, because usually they will be numbers, you just simply add them. So you take the m plus whatever the n is, and you would simplify that, and that would be your answer. So some examples with that. Let's say that you've got x squared times x to the 4th. Okay, and you have to figure out what that equals. And usually with these problems, they'll say something about simplify this expression. And so to simplify it, look at the bases, look at what's going on here. The bases are both x, so that means that they have like bases. And so since you're multiplying them, you simply add their exponents. So remember the base stays the way it is. And then you take their exponents, the 2 plus the 4. And then after you do that, it'd be, well, 2 plus 4 is 6. So it'd be x to the 6th. Okay, so let's do another one. Say we have 2a to the 2nd power times 4a to the 6th power. And we have to figure out what that equals. Well, we've got a couple things going on here. First of all, these numbers are not actually attached to the exponents. The reason for that is kind of what I was talking about up here. These were 3 separate things, kind of. So it's the same thing here. This is 2 times a to the 2nd. So this is kind of like 2 separate things. You've got the 2, and it's got its own power, because remember, like I said up here, if there's not a power or an exponent with it, then remember I told you it would have an exponent of 1. So you always want to put those, I call them hidden exponents, because you can't, they're not going to be drawn for you, so you have to put them in there. And so if it's kind of a number or variable that doesn't have an exponent with it, then that technically means the exponent is going to be 1. So it'd be 2 to the 1st, and then the a has the 2nd power with it. And then you have 4, notice it doesn't have an exponent with it, so you put the 1 as the exponent. So it'd be 4 to the 1st, and then a to the 6th. Okay, so then from there, we are multiplying everything because there's no addition or subtraction between them, and there's not a division bar. And so when you multiply, With the numbers, if they don't have an exponent with them, then you just treat them like you always do numbers. So like the 2 to the first is technically 2, the 4 to the first is 4, and then you just multiply the numbers. So it'd be 2 times 4, which is 8. And then now you've got a base, a variable with an exponent, and then the same base, the same variable, and an exponent that's with that, and you're multiplying them. So remember, like what we did with the x just a second ago, you keep the base the way it is, and then you, because you're multiplying, you add the exponents. So 2 plus 6 would be 8. So altogether we get 8a to the 8th power. All right, so let's do one more and then we'll move to the next exponent rule. So let's say we have negative 3 y to the second times negative 4 x y to the negative second power. All right. Notice everything's being multiplied again, but we also have those pesky little hidden exponents, okay? So with those, if you want to put them, you can put them in there. But for this problem, you'll notice that it won't really make a difference when we do, okay? Because there's not going to be like bases with the hidden exponents. But if you wanted to put them in there, you can. So just like what we did up here, the negative 3 and the negative 4, everything's being multiplied, so you multiply the numbers like normal. So you've got negative 3 times negative 4, a negative times a negative makes a positive, and then 3 times 4 would be 12. And then notice we have an x here, and there's nothing else that is a like base with it. And so if there's nothing else that's a like base with it, that means you just have to bring that over. And so I'm going to go ahead and bring my x over because there's nothing else that will be multiplied with it. And then from there, we have y to the second. And then that has a like base with this one right here. So it's times y to the negative 2. So remember, since you're multiplying, you add the exponents. So technically, it would be 2 plus negative 2. Well, 2 plus negative 2 actually ends up being 0. So we're going to erase this and we're going to write 0. But if we kind of remember the exponent rule from before, when we have something to the 0 power, it actually ends up being 1. So you got to remember the 12 and the x has its own exponent. They're technically to the power of 1. So 12 to the first comes over as 12. X to the first comes over as x, but then y to the 0 ends up being 1. So this would actually be times 1, and that would just leave us with 12x. So 12x would be our answer. All right, so then the next exponent rule. What do we do when we are dividing like bases? Well, if you kind of use a little bit of reasoning and what happened when we were multiplying like bases, you might be able to figure this one out. All right, so this will look like, and I'll use the same letter so that we're consistent. Let's say we have the letter A, and it's to the m power, and this time we are dividing by another A with a different power, okay? So when you are dividing like bases, so let's write our description down. When we are dividing like bases, well, what do we do? Well, when we were multiplying like bases, we added. So kind of reasoning through that, when we're dividing like bases, we would actually subtract the exponents. Okay, so let's kind of talk through some of those. Well, for this problem, we have like bases because they both have a base of A, and so we subtract. And you will find out when we do the examples, there is a little thing you have to remember when you're subtracting as to where to put your answer, but we'll talk about that when we get there. And so if I was to subtract these, we would take m minus n. And then we would have our answer. Okay, so let's do an example so you can see how it works when we actually have numbers in there. So let's say that we have x to the fourth divided by x to the third. All right, so when we have something like this, notice we have a base of an x and an exponent of 4, and then a base of an x with an exponent of 3, and then we're dividing them. So that rule does apply here because we're dividing like bases. And so when we divide like bases, we simply subtract their exponents. But this is the thing that I was kind of warning you about a second ago. When you subtract them, to end up with a positive exponent, and you'll see why I say this in a minute, but to end up with a positive exponent, you have to actually put the answer where the bigger number is. So like if you look in this problem, or where the bigger exponent is. So if you look in this problem, the exponent 4 is bigger than 3, right? So then you would put your answer on the top of the fraction. If it was kind of flip-flopped and you had the x to the fourth on the bottom, you would actually put your answer on the bottom of the fraction so that the exponent ends up being positive. Okay, so for this problem though, the exponent of 4 is bigger than the exponent of 3, so the answer will go on the top. Okay, so on the top of my fraction, which I don't technically have to put it on the bottom or put anything on the bottom because it'd technically be a 1. You put the base, you keep this base the same, and then you take the 4 minus the 3, the bigger number minus the smaller number. And so when you do that, 4 minus 3 is 1. So it'd be x to the first power. And remember, we don't typically put the 1 when it's an exponent of 1, so it'd technically just be x. Okay, let's do a different one so you can see kind of how different problems work with this. Let's say that we have 2x over x to the third. Okay, well, we have a number this time with this problem. So with numbers, remember, you kind of treat them just like you always treat numbers. And so this is a fraction, and technically we have a 2 divided by, well, there's not a number on the bottom, but technically that would mean that there's a 1 right there. So 2 over 1 would be 2. So we could go ahead and bring our 2 over. And then we have to deal with this part. So if you kind of think back to this problem, when we're dividing like bases, we have to subtract the exponents. So when we subtract the exponents, we would take 1 minus the other one. This has a hidden exponent. Remember, if it doesn't have 1, you write it as a 1. And we're going to subtract them. So think back to the last problem I talked about. Your answer actually goes where the bigger exponent is, if you're wanting the exponents to be positive. So when I do this one, notice the 3 is bigger than 1. So I actually have to put my answer on the bottom. So on the bottom, I put x, and then I have to take the bigger number minus the smaller number. Okay, and remember that stays as an exponent. And so when I simplify this, 2 still on top, and then it'd be x to the 3 minus 1 would be 2. And then that's as far as I would go, because with your answers, you want to usually end up with a positive exponent after you simplify. Okay, so let's do one more here, and then we'll move to our next exponent rule. So let's say that we have 16 x to the second, y to the sixth, divided by 4 x to the fourth, y to the third. Okay. Zoom in just a little bit so you guys can see that a little bit better. Okay, so from here, just like the last problem, you treat the numbers like normal. Okay, even if they had an exponent, you could simplify the exponent with them and then treat them like normal. So notice you have a 16 over 4. So 16 divided by 4 is 4. And the answer goes where the bigger number is, kind of like with the exponent stuff. So that's that part. And then notice we have kind of two things going on here. We have the bases that have an x with them, and then we have the base of y. Okay, so you deal with them separately. So we have an x to the second divided by x to the fourth. So when we do this, remember when you divide, you subtract the exponents, and you put your answer where the bigger exponent is. So the bigger exponent's on the bottom, so my answer goes on the bottom. So on the bottom, it would be x to the, well, bigger number minus smaller number. 4 minus 2 would be 2. So on the bottom, we'd have x to the second. And then when I look at my y's, it's y to the sixth divided by y to the third. Well, this one has the bigger exponent on the top. So when I do that, my answer would actually be on the top for that one. So it'd be y to the 6 minus 3 is 3. And then, is there anything else that needs to be simplified? Well, you got 4y to the third, x to the second. There's no more numbers to simplify. There's no more like bases that need to be simplified. So then that is as far as you go. And then if you have extra kind of fraction going on that you created, you can always erase it. Okay. Next exponent rule here. What do you do when you have a power or an exponent to a power? Okay, well, what that looks like is, let's say that we have A times B to the m power, and then all of that is to the n power. Okay, well, that means you have a lot of stuff on the inside of parentheses to an exponent. All right, so that is a power to a power because you technically have an exponent that's brought to another exponent. So when that's happening, so when you have a power to a power, the rule there is you actually multiply the powers. Okay, so remember, when you have a couple things on the inside, like, do you see this A does not have an exponent? Remember, we talked about when it doesn't have an exponent, it has a hidden exponent of 1. So this is technically A to the first, B to the m power, and then all of that, because it's in parentheses, would be to the n power. So when you have to do this rule, it's almost like you're going to distribute this power to all the other powers in the parentheses. So you're distributing exponent to exponent. So like if I did this, it'd be like n times 1 and then n times m. So it's almost like it's distributing, okay? So the bases stay the same. So it's still going to be A, but then it's going to be to the whatever 1 times n is. And so remember, 1 times anything just gives you whatever that number is. So 1 times n would be n. And then you've got to do the same thing with the exponent that's with the b. So it'd be b to the whatever m times n is. And now, because we can't actually simplify that, we just write it like that. Okay, so that is the power to a power rule. All right, let's apply it now. Yay, lead. Gotta love lead. All right, so we've got x squared times y to the third, and then all of that is to the second power. So when you're doing this one, notice you've got a couple things on the inside of the parentheses that have their exponents, and it's all to another exponent, power to a power. So just like we did over here, you have to multiply. It's almost like you distribute this power that's on the outside to everything power-wise on the inside. So this would be x to the whatever 2 times 2 is. And then this one would be y to the whatever 3 times 2 is. Okay, so you distribute your power to each of the powers. And then you just simplify. So this would be x to the, well, 2 times 2 is 4. And then y to the 3 times 2 is 6. And so since they were multiplying to begin with, it'd be x to the 4th times y to the 6th at the end. All right, so let's do one more of these. And then we've got one more rule after that. So let's say we have 8a to the negative 3rd power times b to the 6th. And then all of that is to the negative 3rd power. All right, you got a lot of stuff going on in here to the negative 3rd power. Just like what we did in all the other problems, if you have a power to a power, you multiply the powers. But we do have a hidden power in here, so hopefully you noticed it. This 8 does not have an exponent with it. So because it does not have an exponent with it, you've got to put the 1 with it, because if you forget that, you will forget to distribute that power to all the powers that you're supposed to, okay? So just like what we did in the other problem, you're going to take this negative 3 times each of the powers that are inside the parentheses, okay? So this 8, even though it's a regular number, it still is inside that parentheses. So you have to do the same thing to its exponent. So this would technically be 8 to the whatever 1 times negative 3 is, which is negative 3. And then it would be a to the negative 3 times negative 3. Well, negative times a negative is a positive, and then 3 times 3 is 9, so it would be a to the 9th. And then the last one, it would be b to the 6 times negative 3 would be negative 18. And so there we go. Now, we actually will come back to this problem in a minute because it's not actually all the way simplified according to exponent rules. And so we will come back to it after we learn our last rule. Okay, so we got one more rule to learn. And so let's learn it. All right, the last rule that you have to learn is what to do when you have negative exponents. Because a lot of times with these exponent rule problems, you will be asked to write it so that it does not contain negative exponents. And so you've got to know what to do when you have them. All right, and so that's supposed to be exponents. All right, so let's say that we have the base with a negative number as the exponent. What you have to do to make it positive is you'll always hear me say something like, you move the negative exponents. And so what I mean by that is you have a fraction always with these numbers, no matter if it's a number, a variable, or whatever. And so when I say you move, you actually take the base and its exponent and you move it to whichever side of the fraction it is not on. So like right now, this is actually technically on top of a fraction, because remember, every number is technically understood to be over a 1. And so when you have something like that going on, to make the exponent positive, you actually have to take it and move it to the other side of the fraction. So since this is on top of the fraction, it'll actually move the base and its exponent will move to the bottom of the fraction. And so when I do that, remember I move the base and its exponent, the actual thing that will, or the thing that will happen is that the exponent will become positive. And so notice when I moved it, now it's a to the m power. Okay, and now you might say, okay, well, we don't have anything on top of the fraction. Well, remember, if you don't end up with something on top of the fraction, you just put a 1 on top. Okay, so when you have a negative exponents, so let's write down this description. If you have negative exponents, then what you're going to do is move them, the base and its exponent, to the other side of the fraction. Okay, so let's practice that. Let's say that we have y to the negative 4th power. Well, you don't want negatives as exponents. And this is y to the negative fourth. It's not on the bottom of a fraction. So that means that this is technically kind of like this scenario. It's on top of a fraction. So to make that exponent positive, you have to take the base and its exponent and move it to the other side. So to make it positive, we're going to take the y and the negative 4 and move it to the bottom. But then the 4 magically becomes positive. Okay. And then remember, if there's nothing on top of the fraction, you just put a 1. Okay, let's do another one. So let's say that we have, let's do this one. So let's say that we have x to the first, which remember I don't typically have to put that, over x to the negative 2 power. All right, this base, this x, actually has a positive exponent. So if it's positive to begin with, you actually leave it the way it is. But the x that's on the bottom has a negative 2 as the exponent. So that one will have to be moved to the other side of the fraction so that it will become positive. So you also could, as a strategy, kind of visually, it helps you. You could actually circle the base and its exponent, and you can draw a little arrow to where you're trying to move it so that you can kind of understand what's going on there. And so when I move the base and the exponent, it will all move to the other side of the fraction. So this is a little different because it actually has to move to the top to become positive. And so this x to the first actually stays on top, and then the x to the negative 2 will now move to the top, and now that 2 will become positive. All right, now to actually finish simplifying this, however, this brings in another rule that we've talked about. So if you remember up here, when you are multiplying like bases, so this one right here, you have to add the exponents. So because we're multiplying these, we have to actually take their exponents and add them. So this would actually end up being x to the 1 plus 2 is 3. So it'd be x to the third power when we're done with it. Okay, let's do this problem up here, and then I'll do a little bit, or one that involves a couple different rules so you can kind of understand how that works. So with this one, the reason why we had to come back to it is because notice you have negative exponents. And so with those that have negative exponents, you have to actually move them so that they will become positive. And so the 8 has a negative exponent, so it will have to be moved. The b has a negative exponent. It will also have to be moved, but the a does not. So it'll actually stay on top of the fraction. So both the 8 and the b will be moved, and the a will stay where it is. And so if you, again, want to visually kind of draw yourself what's happening, you can. And then we're just going to move them. So when I move it, the a stays on top. So I'm going to go ahead and write my a to the 9th on top. And then on the bottom, the 8 to the negative third will go on the bottom, and it'll magically become 8 to the third. Let me zoom in just a bit. And then b to the negative 18th will now become b to the positive 18th. All right. Now, the only other thing that you will have to do here is, because remember I said you've got to treat numbers like regular numbers, 8 to the third will simplify. So if it simplifies, you have to simplify it. And so 8 to the third, that's a little bit harder one. But remember, you can use your calculators on the exam. So if you need to type it in, you can. But 8 to the third would end up being 512. And so now everything has a positive exponent, and we've simplified all the numbers that need to be simplified. And so there we go. There is our answer for that. All right. So hopefully we're doing okay so far. Let me see if there's one that's a little bit of one that would take multiple steps, and I'm kind of running out of room on the front side of my exponent rules. So I'm going to flip to the back, and I'm going to show you a way or a strategy that you can use to do some of the harder, more involved problems. Okay, so let me flip over, and if you need to kind of rewind this video, remember you can always rewind or replay whichever parts you want to replay. so that you can refresh your memory. All right. So the thing that you can actually use to kind of remember how to do maybe some of the problems that are a little bit more involved is you can remember this simple acronym, and some of my ladies will know this a little bit more maybe than my fellas, but this lovely little acronym, PMS, will actually help you remember the steps to simplifying these problems. And so, yes, it stands for something else in the outside world, but in math world, it helps us learn how to simplify using exponent rules. So the P in the math world stands for power to a power. So this is actually the first thing you want to do when simplifying harder problems. The next part, the M, stands for move negative exponents, or the ones that have negative exponents with them. Okay, so that's actually the second thing you want to do. And then the last thing that you'll do is simplify anything that's left. So any of the other rules that need to be done, or if you need to simply simplify numbers, like we did that 8 to the third, then you have to do that. All right. So let me show you a little bit of a harder problem so that I can show you how to use these. Okay. So let's say that we have 4x to the negative 2 power y, and then all of that is over x to the third y to the negative 1 power. And then all of this is to the third power. So when we start simplifying this, we have to follow these rules. So the first thing I'm going to look for is the power to a power. And notice we have all of this to the third power. So we definitely have a power to a power. So the first thing that I want to do is use that rule, which remember, power to a power, you have to multiply the powers. So look for those hidden powers first of all. So like my eyes automatically go to the 4 and the y because they don't have an exponent with them. So I'm going to go ahead and draw the 1 that would technically be the exponent with them. That way I don't forget about that. And then I'm going to do the power to a power rule. So remember, you literally take, and I told you it's kind of like distributing that power. So you take that power times every single power that's in here. So now notice, not only do you take it to the powers that are on the top, but you also actually have to take it to any of the powers that are on the bottom as well. Okay. So when I do that, and I know that looks like a mess, but hopefully that makes sense. So when I do that, it'd be 4 to the 1 times 3 power. And then you have x to the negative 2 times 3, which is negative 6 power. And then y to the 1 times 3, which is third, or to the third power. And then you have x to the 3 times 3, ninth power. And then you have y to the negative 1 times 3, which would be negative third power. All right. So hopefully that kind of made sense as to you distribute your power. Then from there, if you have negative exponents, then you move your negative exponents. So you have 4 to the third, so that doesn't have a negative exponent, so it won't move. Then you have x to the negative 6. That has a negative exponent, so you've got to move that. Then you have y to the negative third. That has a negative exponent, so you've got to move that one, okay? So now notice these that don't have a negative exponent are going to stay where they are, okay? So if you want to go ahead and leave them and write them as your fraction, like this y to the third is going to stay where it is. The x to the ninth will stay on the bottom. So you can go ahead and leave them. And then these, like this one, will move to the bottom. So I'm going to go ahead and move that to the bottom. And remember, the reason you move it is so it becomes positive. And then this y to the negative third is going to move to the top. So the y to the negative third will move to the top, and the 3 will become positive. All right. So now after that, you simplify anything that's left. So this 4 to the third will simplify. So 4 to the third is 64. And then notice you have like bases in your multiplying. So the rule there is you add the exponents. So 3 plus 3 is 6. And remember, it stays an exponent. And then on the bottom, you've got x to the 9th times x to the 6th. So again, when you multiply like bases, you add the exponents. So 9 plus 6 would be x to the 15th power. And then you look, is there anything left over to simplify? Well, we've simplified our numbers. There's no more like bases. And so this would be our final answer.